This device is called fine beam tube, where you can see the electron beam, in the presence of magnetic field. So, as you know, the charged particles makes a circular path in magnetic field, right? So that's what we will see actually. So first of all, this right here, this device right here at the bottom of this bulb, right, is called the electron gun, and its job is to shoot the electrons. So what happens is, first a filament is heated, by applying certain, like 10 volts, using this voltage goes to the filament and it hits the filaments, and the filament releases electrons, and these electrons are then accelerated by using about 300 volts, 300 potential difference in this electron gun. And as you can see, this bluish color, right, horizontal bluish color, that's the shooting of electrons, that's the actual electrons. But this bulb is filled with some hydrogen or helium gas to make the electron beam visible. Otherwise electrons will be invisible. But the beam you see here, right here, is the electron beam. And we apply magnetic field using this pair of coils called Helmholtz coil. This is called Helmholtz coil. So it has many number of turns, this pair of coils. And when you apply DC current through this loop, through this coil, it produces uniform magnetic field at the bulb in this region, right? So its job is to provide the uniform magnetic field. And then we will change the magnetic field, and then we will see what happened to the radius of the electron beam. And I can change the current in the Helmholtz coil that I just showed you by changing the current, by changing the voltage applied to the Helmholtz coil. So this power supply right here, it supplies the power to that Helmholtz coil. So then I can slowly change the voltage, right, and then it changes the current to the coil, and you can see. Let's try to see, otherwise I will have to make more darker. So I'm increasing the magnetic field by increasing the current in the coil. As you can see, the electron beam, right, see, electron beam just make a circle at some point. See, just make a circle, and as I increase the magnetic field, its diameter decreases, its radius of curvature decreases as expected, right from the formula. So see, the beam you are seeing right here is the actual electron beam, okay, that is emitted by this electron gun from the filament, which is being accelerated by 300 volts. And I'm decreasing the magnetic field again, and again increasing the magnetic field. So let me show you in a more darker environment. Now it's it's more clear now. As you can see the electron beam, right? So right now what you see is just a stream of electrons emitted by the electron gun, right? As you can see right here. Now I can curve it by increasing the magnetic field, right? And at some point it just makes a curve, right? And then if you keep increasing the magnetic field, the radius of curvature decreases as we expect. See, and you can shrink it by increasing the current in the coil. So that the beam you are seeing right here is the actual electron beam.